Hello everyone. Today we will be exploring the exciting world of QUIC, the new Internet Transport Layer Protocol that aims to improve upon TCP and provide a more secure and efficient way of transmitting data over the Internet. So first we will start with a quick overview of how traditional HTTP work over TCP. Then we will dive into what QUIC is and how it's different and why it matters. So we have got some great visuals and live packet captures demos to make this engaging and easy to follow among. So let's start with the Wireshark. So we have already opened the Wireshark. As you can see that we got a lot of packets which has the TCP, HTTP, TLS, SSD, UDP, and all about it. So all out throughout the trimester, we have learned about this packet. Now we are gonna quick overview about the QUIC. So first we're gonna open the chart here. So as you can see that as a refresher, let's look at how traditional HTTP web traffic work using TCP, and I'm gonna explain the diagram of uh, TCP and HTTP over TCP showing head of line blocking issue. So this is the HTTP client sending request over TCP to the server. While TCP is a reliable transport, its serial nature means if a one packet is lost or delayed, it can block and delete all other packets until it's received. So this is called head of the line blocking and can really hurt performance. Now you can see that client intending TCP connection with seen and acknowledge handshake. Data is then exchanged over this order TCP stream, but if any packet doesn't arrive, it causes whole blocking. Now we're gonna start reviewing our QUIC. So let's have a look with the diagram first. So I'm gonna just close this. Yep. So as you can see that I have already put all the diagrams here. So there's a difference between TCP and QUIC. So TCP is probably gonna work with the both the protocols work with the client and server, but when TCP it's like work with the sync and acknowledge like client hello and client finish. So when client send a packet to the server, so it goes with the sync and acknowledge. It says to the TLS through the TLS network, it says client hello, and when with the server when the package is received by TLS, so the server hello sends a message to the TLS that the package is received and all the process is finished. Now we're gonna quick have a look with the QUIC. So it's basically both client and server. So it says that initial client hello beginning before the package sent by the server, and then it's gonna says initial hello certificate when client is finished. Yes, this is what it is about the TCP and QUICC. Now we're gonna have a look on the table given here. So this is basically a table which has all the protocols, comparison of IoT application layer protocols. So as you can see that MQ22IT, which we just make the Cisco packet using this when we was executing the smart home application. So that's all the information about the scope, MQTT scene, and all about the things here. Now we're gonna explore the QUICC protocol. So let's start. So QUICC, we're gonna write QUICC here. Sorry. Let's start with the QUIC. QUIC, sorry. Yes. Yes, so as you can see that we have all QUICC protocol here. So QUIC or Quick UDP Internet Connection is a new transport protocol as we know that developed by Google and now an internet standard. So as we explained before that it runs over UDP rather than TCP. So this is the protocol that we're gonna explore first. So as you can see that here QUIC connection information, and first we're gonna have a look about the TLS, which is the handshake protocol using client hello message. So this is the basically the first part of the QUIC. So by using UDP and QUIC avoids TCP head of line blocking issues entirely entirely lost package, don't stall the entire connection. So it also has built-in security as we can see here that TLS 1.3 encryption. So you can see here the client is sending initial UDP datagram to the server. So it's encrypted with the TLS 1.3 from the start. This secure multiplexed connection avoid hole blocking. Let's start with the different packet given here. So as we can see that all the information about uh, packet lengths that header from long header, fig byte is true, and we're gonna check the packet number as well. The packet number is stored, so token length is 0, as well as we're just gonna explore the padding lengths given here. So that's a lot of things here to explore. So when you run the workshop, you can explore each and everything. And then we're gonna just um, let's start. Yep. So this is the ping given for the packet here. And now we're gonna explore the server hello packet. Yes. Here you can see that says server hello. So but QUIC is a more about than just UDP, so it incorporates advanced technique like stream multiplexing over a single connection to be faster and more efficient than TCP. So now we're gonna explore QUIC key features. So what exactly are the key features and benefit of QUIC over TCP? Let's break it down. So QUIC is a connection migration. So it has ability to seamlessly migrate connection across network changes without dropping. And there is another one thing that I'm gonna explore here that says ORTT connection that can authenticate and encrypt data on first packet with zero RTT if cached. Alright, and there's another one thing we have to notice that stream multiplexing allows multiple streams over one connection to avoid head of line blocking. And there's another thing that QIC stands for is better combination control. So it uses modern loose-based combination control for better performance. So it has security encryption authentication as we explored here, that it has TLS 1.3 encryption that protects all the packets, and it also gives the encryption and authentication integrate into the protocol with that TLS 1.3. So now let's look at some live QAICC traffic here. So now we're gonna just, yep. So now, you can see here the client is sending its crypto handshake data over UDP rather than TCP. So the server responds with its cut and finished, then application data starts streaming over the secure QUIC connection. So we're gonna just have a look server hello as well here. Yes. So this is the handshake protocol, which is the client protocol, client hello. And when we're gonna just do the same thing with the server hello, it has the same encryption. So we're gonna just, yep. So as you can see the server hello here. All right. So now we just compare the performance that QUIC plus TCP. So we're gonna just have a look our chart. So, yep. So now we just gonna have a look about performance test. Have someone QICC. Sorry, not this one. Yep. So now we're gonna just explain the performance test when I have someone in the output outgoing TCP. So especially in more congested environment with technologies like stream multiplexing QIC can achieve higher throughout and lower latency compared to the TCP. So you can see this example when sharing a bandwidth with TCP flows, the QIC flow is able to sustain higher throughout. So in conclusion, we just say this that QIC an exciting new internet transport that provides a more robust, secure, and high performance solution compared to the older TCP protocol. While TCP will continue to be used, QUIC is seeing rapid adoption for many web series. By running over TCP, by running over TCP and UDP, avoiding head-of-line blocking, integrating security, and enabling multiplex streams, QICC is really the future of internet data transmission. It's been too great exploring this protocol together today. Thank you so much for the video.